Good morning, good evening, and good night. Depending on which time you are going to observe this lecture. Welcome to the 6th lecture on the electrochemistry. In this lecture, we will be going to discuss a very important application of the electrochemistry. That is the different type of batteries and its cell reactions and its applications that we are going to discuss in this lecture. So, heading of today's video is the types of batteries. This is KK Mukherjee in the Science with Mukherjee Sir YouTube channel. What is battery? Let us understand that we already know that it is a very widespread applications in your day-to-day life. Without this battery, we cannot able to do anything, because battery has been used in clocks, in watches, in any electrical applications, all the things that has been used, the battery has been used in those applications. So what is battery? Let us understand. Battery is basically a source of electrical energy. It is basically a galvanic cell which converts the spontaneous redox reaction into that is a chemical energy that convert into the electrical energy. And the most useful thing, most requisites of this battery, that it should be light enough so that we can able to transport it. It should be compact, and the voltages should not vary much in this battery. There is three aspects that going to have in a battery. For a good battery, it should have all those characteristics. So now let us understand types of batteries. What are the types of batteries? Let us understand. Type of battery. Battery, or you can say it is a cell. There is three types of battery that you can see. Number one, that is the primary battery. Number two, that is the secondary battery. These three types of batteries that we are going to discuss, that is number one, primary battery, secondary battery, and fuel cell. First, let us understand what is the primary battery. Primary batteries are those batteries where the reaction has occurred for once, and after the use of the battery, it become dead one, and means that battery cannot be recharged for using. Once the battery has been used, you have to throw it out. So this type of battery we will call it is a primary battery. Normally, the most familiar primary batteries are number one, that we are going to discuss, one that is the dry cell, and second that is the mercury cell, or you can say mercury battery and dry battery. Every cell, or you can say every battery, it is having the three components, three constituents that we understand. The first constituents, it should have anode. Second constituents, it should have the cathode. Third, that is the electrolyte. Electrolyte, where the electrolyte three constituents of a battery, three principal constituents of the battery. With these constituents, the battery is going to be formed. Let us understand for the dry cell what will be the anode and what will be cathode and what will be the electrolyte. For the dry cell, you will find that it is basically dry cell. You can see that here you can, this type of things, that is a zinc container. In that zinc container you will find that is here is a rod, graphite rod is there. This is a zinc container and here it is a graphite rod, and this zinc container is the anode. So we can write the zinc container is anode, zinc container. Zinc container is anode, and cathode is the graphite rod. This is basically carbon rod and it is basically a graphite. Graphite rod is the cathode. And here electrolytes, you can observe there is two parts. One, that is a paste of ammonium chloride plus zinc chloride, which is attached to the zinc container, and second part of this electrolyte is MnO2 plus carbon that attached to your cathode. So we understand these three components of this dry cell. This is we are talking about the dry cell. It is having one zinc container. In that zinc container there is a cathode. Zinc container is the anode, and in this zinc container there is a cathode as the graphite rod. That you can see any type of battery pencil cell, that there is a one container type, and at the middle of this container you can see this type of rod is there. It is basically a graphite rod. It is acts as a cathode, and the electrolyte is ammonium chloride and zinc chloride, and MnO2 and carbon dust it is also used as a paste, and it is being put there, and it is around the cathode rod. This is the constituent of the dry cell. Now, what are the reactions that we know? For producing the electricity, you have to have some cell reactions. There are two half cells. In the anode half cell, you can see in this battery that at the anode half cell, the zinc solid, it will be oxidized and it is going to produce the zinc, this, and it is produce the two electrons. At the anode, there is a two electrons will be produced, and in the cathode, there is the reaction is this MnO2 plus ammonium, this NH4 plus ammonium ion plus 2 electron, and this is going to produce Mn2O3 plus ammonia gas plus H2. So this is solid. Ammonium MnO2 is solid and MnO2 is also solid, and it is in the aqueous medium. So it is going to produce this. Here you can see in the cathode reduction is taking place. The MnO2 has been reduced to, here the oxidation number of Mn is +3 and is +4, and it will going to create the voltage in the cell, and it will have the ability of producing the electricity. And another thing, this ammonia gas also react with the zinc chloride. Another thing that we have to see, we have to balance this reaction. For this balance reaction, you have to give 2, and this is 2, and you will get 2. So you will see it is balanced. Hydrogen is balanced 6, 8, and manganese is balanced 3, 4, and it is also find this. Okay. Second reaction, that ZnCl2 with the ammonia gas, it is going to produce a complex is formed here. This complex is formed. So this is the reaction. So this is the total reaction in the dry cell. I can see the anode is zinc container, graphite rod is the cathode, electrolyte is the manganese dioxide plus carbon which is attached to the cathode, and the zinc container, and the ammonium chloride and ZnCl2 is in this container. Now what is the voltages of this cell? In this cell, the voltage is 1.5 volt, and it is used in transistors, clocks, different types of applications where there is a need for higher amount of electricity. So this is the dry cell. Now we are going to discuss the mercury cell. Now we are going to discuss another very important cell, that is the mercury cell. Mercury cell, just like in the dry cell, you will find there is a anode. Anode is the zinc amalgam. Zinc amalgam is anode. Cathode is, you find, that is, it is having AgO plus carbon dust. Number 3, electrolyte. Electrolyte you will find, that is, here use electrolyte is KOH paste. KOH paste is electrolyte. So anode is zinc amalgam. Zinc amalgam is anode. Then cathode is AgO plus carbon dust, that is in the paste form, and here electrolyte is used the KOH. So what will be the reaction in the mercury cell? Let us understand. In the anode, the reaction will be this: zinc plus, this will react with the OH minus. OH minus is coming from the KOH paste, and it is going to produce zinc plus 2 plus 2 electron, and it will giving H2O. So no, this is here produce ZnO. So zinc plus zinc with the KOH with the OH minus will oxidize this Zn, and it will be ZnO, zinc oxide plus 2 electron and H2O. In the cathode, the reaction is this: AgO plus H2O plus 2 electron. Here so this is the reaction at the anode, and this is the reaction at the cathode. So overall reaction, you can see this is this. So this is the overall reaction of the mercury cell. In this cell, it is producing, its voltage is slightly less than dry cell. Its voltage is 1.3 volt, and it is basically used in those applications, in those devices where you need the lesser current, like your hearing aid. Hearing aid, you will use this. Now, then you will use, that is in your watch, where the electric current, necessity of the electric current is less. So this is the mercury cell, and mercury cell is much more have the longevity than the dry cell, because here everything in the, there is no aqueous things here, that is only you will find every ions are produced in the dry state. So there is a lesser probability of damaging, and the cells and the voltage in the cells will be very much consistent throughout its life period. So that is two cells we have discussed. One, that is first we have discussed the dry cell. Second, discuss the mercury cell with its application and the reaction. Now we are going to discuss the very important cells, that is the secondary cells. We discuss another very important cell, that is the secondary cell. Secondary cell, that is a very important type of battery or cell, you can say. Secondary, let us write is battery. Secondary battery. What is that? It is basically those cells, those battery which can be recharged, and we can use this further. After recharging these cells, that we can use it further, and that is called the secondary cells. And the good secondary cell is one which can be recharged and which can be charged for a number of times. Then we will call it is a very good secondary cell. So secondary cell, basically the two type of cell you can see. Number one, that is the lead storage cell. Lead storage cell. Lead storage battery. And second is the cadmium nickel battery. Cadmium nickel battery. These two type of battery that you can see, that is lead storage battery and cadmium nickel battery. The lead storage battery, let us understand. Lead storage battery. Lead storage battery is that this battery is very common. We use in cars, we use in inverters, and that you can see in our day-to-day use, that in your room also, in your house also you can find that this type of battery is used. In the car you can see there is a battery in the car, which battery has been put, it is basically lead storage battery. Anode, that we know every cell have three constituents: anode, then that is the cathode, and last is the electrolyte. In this lead storage battery, the anode is PB, lead. In the, you can see, if you observe this battery in your room, which is used in the inverter, you will find that there is a lead plate. Thus, this lead plate is basically used as the anode. In the cathode, you will find lead plate is there, and it is been covered, it is been equipped with the PbO2 solids, that is been put in the total grid, has been totally covered up with this PbO2 and this PbO2 here as a cathode. And here electrolytes is 38% H2SO4 is electrolyte. So this is three components of lead storage battery. Now what is the reaction? In the anode you can find this reaction PbSO4 2 minus, that is coming from the sulfuric acid, and it is being oxidized by SO4 minus. It will going to produce the PbSO4 plus 2 electron has been released from it. Okay. In the cathode, the reaction is PbO2 plus SO4 2 minus, and it is going to, and here you have to balance the 4H plus 2 electron, and it is going to produce again PbSO4. Reaction for the cathode also, and overall reaction you will find Pb plus PbO2 plus H2SO4 and H2SO4, that will be 2 H2SO4 and 2 PbSO4 plus 2H2. So this will be the overall reaction, and this is the discharging reaction. Discharge. The way that we are taking the electricity from this lead cell, that you will find this type of reaction. But when it is charging, when we are charging, the reaction is going on in the opposite direction. Where the secondary battery. In the secondary battery, you can see that it can be recharged, and here battery, that is the cadmium nickel battery. In this cadmium nickel battery, here you can see cadmium that is used as a anode, and nickel oxide is used as a cathode, and in this the electrolyte is, that is the concentrated, that is a KOH solutions. KOH solution used as a electrolyte. So this is three things that is very important. Cadmium is used as anode, Ni2 is a cathode, and this. So what will be the reaction? Let us understand. In the cathode, in the anode, that is cadmium will react with the OH minus ion, and it will produce cadmium hydroxide, and 2 electron has been produced. And in the cathode, this reaction is going on. This is, and it will produce nickel oxide plus 2 OH minus ion. So you can see this is the balance of 4, and this is 4, and this is 2, 4. This is the, so this is the reaction is the cadmium nickel battery, and you can see in the anode this reaction is occurred, in the cathode this reaction occurred, and this cell is expensive, and it can also be recharged, that you can able to use it after the of cells that we have discussed. That is a very important cell. And another cell that we are going to discuss, that is the fuel cell. Now we are going to discuss the fuel cell. Fuel cell is basically a important type of cell that has been utilized the chemical energy of the fossil fuel. Fossil fuel, that is the coal, gas and oil. Normally in the thermal plant, what we observe? We observe all these fossil fuels, that is the coal has been burnt, and this heat of combustion is utilized to convert the water into the high pressure steam, and this high pressure steam will run the turbine to produce the electricity. But in the heat of combustion of these gases, that is hydrogen gas, oxygen gas or methane gas or methanol, has been utilized to use its chemical energy, that is heat of combustion, into the electrical energy. And how they are doing? That is a basically arrangement. It is called the galvanic cell. In that, what is going to happen? You can see we are taking the example of the fuel cell, that is H2O2. H2O2 is the fuel cell, and here this arrangement has been made. Type of arrangement is there. That is the cathode. In the cathode, that you can say oxygen has been flowed, the oxygen will bubble. In the anode, this is anode and this is cathode. In the anode, the hydrogen has been bubbled. Here, this is a perforated carbon rod, and in this carbon rod, hydrogen will flow and the oxygen will flow, and in between there is the electrolyte. Electrolyte here is the concentrated hydrogen NaOH, concentrated NaOH, sodium hydroxide, and this is the electrolyte. Here the continuously the oxygen and hydrogen has been flowed, and there is a reaction is going on here, and in this reaction there is a production of H2O, and this H2O steam has been carried out, that has been taken out from this cell, and you will find there is a production of a electricity. Here it is the anode and here is the cathode. This is the H2O2 fuel cell, that you can understand. This is here, there is a two rod is put, that is basically the perforated carbon rod. Perforated carbon. Perforated carbon is basically the two electrodes, that is the cathode and the anode. And what is the reaction is going on, that is, let us understand. In the anode, this reaction is going on. This is hydrogen plus OH minus. This is going to produce the 2H2 plus electron. This is the anode reaction. And the cathode reaction, that you can see, so this is the cathode reaction and this is the anode reaction, and total reaction is this. Total reaction is this. So in this reaction, you can see there is a transfer of the electron, and that has been utilized to produce the electricity, and it has been observed that it is having a efficiency around the 85% as compared to the thermal plant where the efficiency is only 40%. So this fuel cell is being used nowadays to produce the electricity, and it is very much efficient, and now a lot of development is being carried out in this fuel cell. So that is all for today's lecture. In this lecture we have discussed the different types of batteries and their different applications, and how the cell reaction, how their chemical energy has been converted into the electrical energy, that we have also discussed. So if you like this lecture, you can share with friends, and thank you for watching this lecture.